Welcome AP Stats students. We are moving on to our fourth section. In this lesson, we'll be diving into the displaying quantitative data with numbers. We'll learn how to find and interpret key measures like the mean, median, range, standard deviation, and interquartile range, and how to make sense of them through visual summaries like box plots. By the end of this section, you'll be able to describe a data set using numbers. You'll calculate the mean and median, assess variability with range and standard deviation, and identify outliers using the interquartile range. You'll also learn to use box plots to compare data distributions. Now, bear with me, as this lesson is a little longer than the last ones. So let's start with the median, the midpoint of a data set. If you line up your data from smallest to largest, the median is the value in the center. If there's an even number of data points, the median is the average of the two middle numbers. It's a measure of center that resists extreme values. So the median is resistant. Here's a quick example. We're finding the median population density for Central American countries. Sort the values and find the one in the middle, or average the two middle ones if there's an even count. So we're going to arrange them from smallest to largest. There is an odd count, so our middle number is 82. We can verify this visually by using a dot plot, and you can see that that would be the middle number. Next up is the mean, commonly known as the average. And in order to find the mean, we're going to add up all the values and divide by how many numbers you have. It's also a measure of center, but is not resistant to outliers. Here's an example of percent error in the small sample 14 bags of chips. To find the mean, we'll be able to add up all the percent error and divide by the total number of samples in this case, which is 14. So when we do that, our mean would be 42.57%. Now, for instance, here it says calculate the mean percentage in the bags if you exclude the Fritos. What do you notice? So in this case, in this chip bag experiment, including a bag with a very low percentage of error drastically lowers the mean. So notice how it went down. Now, some quick terminology that we need to check. So the first one is statistics. Statistics describes a sample, while a parameter describes a population. Now, the symbol, when we talk about a statistic, when we're talking about mean, it's X bar. And if we're talking about the population mean, which is the parameter, we use the symbol mu. Now, a couple things we have to remember that we just talked about is we need to remember that mean is not a resistant of measure. It gets pulled in the direction of the skewed data or outliers, okay? Median is a resistant measure. So if I have an outlier, it's not going to affect it. Now, we do also want to remember symbols. Just think about when we're talking about statistics, it starts with an S, so that's about samples. While parameters, which starts with the letter P, talks about populations, because we are going to be using these two words quite a lot throughout AP Stats, so you do need to know if we're talking about a sample or a population. Now, when a distribution is skewed, the mean and the median won't be the same. The mean is dragged towards the tail, so we use the median in those cases. Comparing the two gives insight into a distribution's shape. Now, when we compare the mean and median, when we're talking about the shape, okay, notice here that it is skewed to the left. So that means that the mean is going to be pulled to that lower end, and the median will be greater than the mean. And now here, when it's symmetric, roughly symmetric, notice that these two values, both the median and the mean, are going to be roughly, approximately the same. And then here, notice that this is skewed to the right. The mean is getting pulled by those higher numbers. So that means that the mean is going to be greater than the median. Now, this is important skills that you really need to grasp because we will be using this a lot throughout the course. So just remember, the mean is pulled in the direction of that long tail in the skewed distribution. Now, the effects of skewness and outliers on measures of center. So if the distribution of the quantitative data is roughly symmetric and has no outliers, then remember the mean and the median will be similar. If the distribution is strongly skewed, then the mean will be pulled towards the direction of the skewness, okay? And then the median is the one that's resistant to outliers, but the mean is not. So just as a refresher, symmetric, mean and median will be approximately the same. If it's skewed right, the mean will be greater than the median. Skewed left, the median will be greater than the mean. Okay, and don't forget the median is a resistant measure of center. Now let's discuss range. The simplest measure of spread. It's just a difference between the max and the min values. So, for example, in this case where it says a supplier A has much tighter range than supplier B, if we look at them showing less variability. Notice how close these are versus how spread out these are here. And remember that the range is not a resistant measure, so it does get affected by those outliers. Now, standard deviation shows how spread out the data is around the mean. It's calculated by finding the average of the squared differences from the mean, then taking the square root. So let's walk through this step by step on how to find the standard deviation. Now, how do we actually calculate the sample standard deviation? So the first thing is to find the mean of the distribution. Then you're going to find the deviation, which is you're going to get the value minus mean. And you're going to do that for each of the terms. And you're going to square each of those values. And then you're going to add up all those squared deviations and then divide by n minus 1 to get the sample variance, which is S sub x squared. Now, couple key properties. Standard deviation is always a non-negative, and it does increase with a greater spread. And it is not resistant to outliers, so it is affected by those outliers. Now, let's look at this problem here, where it says 11 high school students were asked how many close friends they have. So it's a survey. So we want to find the standard deviations of this. So the first thing is we need to find the mean. So we're going to add up all of these, divided by the total, which is 11, and we get 3. Now we're going to find the deviation. The deviation for each one, we're going to do the value minus mean, and we get all those values. The next step is to square those values, and then we're going to add them all up. Once we have that, we're going to do 11 minus 1, which, because there's 11 students that we did, and we get 1.8. And that's going to be our variance. And then to find our standard deviation, we're just going to take the square root of that, and it's 1.34. So if you notice, this is the variance, while when we take the square root of the variance, we get the standard deviation. And we make sure that we write it in the correct units, which we were talking about close friends here. Okay, so these are the properties again, because it's extremely important that we remember. The standard deviation is always greater than or equal to 0. The greater the variation from the mean result is larger values of that standard deviation. The standard deviation is not resistant measure of variability. And the standard deviation measures variation about the mean. Now, measuring variability using the interquartile range. So we remember how to do a dot plot, and what first we need to remember are what the quartiles are. The quartiles of a distribution divide an ordered data set into 4 groups having roughly the same number of values. To find the quartiles, you're just going to arrange the data values from left to right, from smallest to largest, and then find the median, so which is there. Then you're going to go ahead and find the median of the lower data and then the median of the upper data in reference to that median. So our first quartile is going to be at the lower end over here, and our third quartile is going to be over here. So here's quartile 1, here's quartile 3, because that's the middle of this upper data, while this one is the middle of that lower data. And the quartiles can help describe the position of an individual's value in a distribution of a quantitative data. Now, the IQR focuses on the middle 50% of the data. So we're going to find the first and third quartiles. So we found Q1 and Q3. And we're just going to subtract Q3 minus Q1 to actually get the IQR. Now, it's a resistant measure, and it does help you access variability while ignoring extreme values here. So again, the IQR is Q3 minus Q1. Now, finding the IQR for the CHIPS data set that we looked at before. We're going to sort the values from smallest to largest, and we're going to find the median. Then we're going to go ahead and find the first quartile, which is going to be in the middle data. So notice that this number, we didn't use it, so it's part of the lower data. And that's going to be, the one in the middle is going to be our Q sub 1. And then we're going to do it with the top data, with the upper data, and we're going to find the middle, which is 49. So to find the IQR, we're going to do Q3 minus Q1, and we end up with 10% error. Now, how do we know which measures of center and variability to choose? So the median and the IQR are usually better choices than the mean and the standard deviation for describing a skewed distribution or a distribution with outliers. Now remember, the X bar talks about the mean of the sample, and S sub X is a standard deviation of the sample, and that we use when it's roughly symmetric distribution and that they don't have any outliers or anything. Okay, so as a refresher, if it's symmetric, use the mean and the standard deviation. If there's outliers or if it's clearly skewed, we want to use the median and the IQR as a measure of variability and center. And now we use a range to measure variability only as a last resort. Now, which measures of center and variability are best to summarize this distribution? Okay, so we're going to look here and we're going to identify, is this symmetric or is there a skewness? Well, notice it does look skewed with a possible outlier. Since that's the case, we want to make sure that we use the median because that's a resistant to outliers, and we want to use the IQR here. Okay, so again, we're going to use the center as the median, and then our IQR as our variability here. Now, you can do all of this instead of plotting them by hand. You can watch this video and it will show you how to do the box plot and the dot plot on the graphing calculator. We'll also practice it in class, but you can start watching this to start advancing. Now, outliers are data points that fall far from the rest. They might be mistakes or interesting anomalies. We detect them by using what's called the 1.5 IQR rule. So for example, in this one, it says LeBron James rookie and peak scoring season are outliers in the overall performance. So if you notice the outlier there, we're going to verify if this is an outlier by doing the 1.5 IQR. And the 1.5 IQR, all it is that you get Q1 and you minus that by 1.5 times IQR. If that number is bigger than any other number below it, then there's going to be a lower outlier. If you do Q3 plus 1.5 times IQR, and that number, there's numbers that are bigger than that, then those are going to be high outliers. So here, do we have that LeBron's points per game seem like outliers? And that's what we're going to check. So what we're going to do is we're going to look. They might be inaccurate data values. We don't know. They can indicate remarkable occurrences, and they can heavily influence the values of some summary statistics like the mean, range, and standard deviation. So what we're going to do is we're going to do the 1.5 IQR rule. So we're going to find the IQR. So we're going to arrange all the numbers from smallest to largest, find the median of the lower numbers, and find the median of the upper numbers. Once we have that, we can get Q3 minus Q1, and that's going to be our IQR, and we're going to substitute what Q1 and Q3 here is. And any number that's smaller than 24.45 is going to be an outlier. So notice here, this number is going to be an outlier. Any number that's the Q3, which is 27.95, plus the 1.5 IQR, which is 30.05, anything higher than that will also be an outlier. So notice here, this one looks like a higher outlier there. So if we want to write it in context, which every single number that we are going to represent in AP Statistics has to be in context. You cannot just leave it hanging around. So here, LeBron James' rookie season average of 20.9 points per game is a lower outlier because it is less than 24.45. The season when LeBron's averaged 31.4 points per game is a high outlier because it's greater than 30.55. Now, when using the 5-number summary, which includes the minimum, quartile 1, the median, the third quartile, and the maximum value, once we find those, we can then go ahead and make what's called a box plot. And a box plot is a visual summary using the 5-number summary. It clearly shows the center, spread, and potential outliers of a distribution. So notice this would be an outlier here. Now, with the 5-number summary, we can identify the outliers using the 1.5 IQR rule. Then we draw and label the horizontal axes, scale the axes, and then, of course, draw the box. Mark the median, draw the whiskers, and then identify what your outliers are there. So notice here, we're drawing the box. And of course, we mark our outliers there. Now, box plots are great for comparing groups. Take the example of tablet ratings. Apple's ratings are more consistent because slightly higher on average. Samsung's vary more, use and then we're going to use comparative language when we're describing them. So say one is greater than the other, not just higher or lower. So it's very important when they ask to compare something that you use those comparative language in order to receive credit. Now notice here we're going to describe them, okay? So remember what we're going to use. We're going to use our acronym SOX. So we're going to talk about the shape. So both distributions, our overall ratings, are skewed to the left. So we're describing both of them. And don't forget, we do need to write it in context. We're going to go to outliers. So here there are 2 low outliers in the Apple tablet distribution with overall ratings of 73 and 76. The Samsung distribution has no outliers. Then we're going to talk about the center. The Apple tablets had a slight higher median overall ratings, 84. You do want to make sure that you state what the medians are. And the Samsung tablet, 83. More importantly, about 75% of the Apple tablets had overall ratings then there were greater than or equal to the median for the Samsung tablet. So you are using comparative language there. And then the spread, which talks about the variability. So here, there's much more variability in overall ratings among the Samsung tablets than among the Apple tablets. The IQR for Samsung tablets is 11, is almost 4 times larger than the IQR for Apple tablets, which is 3. Now, again, I want to stress this because it is important to use comparative language. If you don't use it, they will not give you credit if you just list what each of them are. You do have to use something is greater, something is less than, but you do need to use comparative language. So to wrap up, always choose summary statistics based on the data's shape and outliers. Median and IQR for skewed distribution, mean and standard deviation for symmetric ones. Box plots let you summarize and compare distributions clearly.